With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a capacitor or capacitance C which is charged by a battery at 2 or we can say that at V volts and then disconnected. Now t equals to 0, it is connected to an uncharged capacitor or capacitance 2C and resistance R. The charge on the second capacitor as a function of time is given as to be Q equals to alpha CV divided by 3, 1 minus e to the power minus 3t divided by beta RC. So we just write it clearly. So the bracket term is given as to be this term. It is given as to be e to the power minus 3t divided by beta RC. Now we need to find what is the value of alpha by beta. First of all, we just draw a circuit. So this is, let's say, initial part, and this is the second case. Now in the initial case, we are just having a capacitor connected with this battery. Now the capacitance is C and the voltage is V. So it would be basically it is charged. So we can say that the potential difference that would be existing across the plate of the capacitor would be equals to V. So the charge developed would be equals to CV. Here it would be CV, but this would be positive, this would be negative because it is connected to the positive terminal. Now what has happened? Now we disconnected this battery, okay, and through this capacitor we connected a resistance. So let's say this is our resistance, okay, and also we have connected a capacitor of capacitance 2C. So here we have connected a capacitor of capacitance 2C. So we call this as to be our 2C, this is our C, and this is our resistance. Let's call the value to be R. Now what will happen? So initially it would be having a potential V, and the charge that would exist here, it would be equals to CV. Now for example, now it would be basically it would be discharging. So at any instant of time, let's suppose that this capacitor gives a charge Q, okay, because it would be discharging, so it would be supplying the charge, and due to which there would be this current which would be flowing. So that means what would be the charge which would be existing for our capacitor, this 2C. So it would be Q, and for this plate it would be minus Q, okay. Now if Q amount of charge is given by the capacitor, what was the initial charge? It was CV. So what would be the charge that would remain on the capacitor? It would be CV minus Q, okay. So this would be positive for this part, negative for this part. Now we can see that, so the total potential which was existing for our capacitor would be dropped in the capacitor 2C as well as in the resistor R. Now in this case, if let's say due to the flow of the charge Q, the current which is developed is I. So we can say that I value would be equals to dq divided by dt. Okay, this is, let's say, equation 1. Now if we just apply our this potential balance, we say that the potential difference, potential which is given by our capacitor C, which is equals to CV minus Q divided by C, because potential for the capacitor is charge divided by the capacitance. This would be dropped in the resistor, so it would be IR, plus it is dropped in the capacitor, which is capacitance 2C, so it would be Q divided by 2C, okay. Now we know that I could be written as dq by dt, so we can say that it would be V minus Q divided by C. This would be equals to R dq divided by dt plus Q divided by 2C. Now we can just make it to the same side, so we can say that it would be V minus, now if we bring to the other side, it would turn out to be 3Q divided by 2C. This would be equals to R dq by dt. Now if we just rewrite this expression once more before integration, so we can just say that 2 times CV minus 3Q divided by 2C, this is equals to R then dq by dt. Now what we can do, we can just take Q terms to the dq side and remaining term to the dt side, so we can say that dq divided by 2CV minus 3Q. This would be equals to, if we take dt to the other side, so in the denominator it would be 2C multiplied by R. So we can say that 2RC. Now what we can do, we can just integrate it. Now we know that at t equals to 0, there is no value of small q, okay. So we can say that it would be equals to 0. Now at any time t, let the charge is Q. So it is just a simple integration. It would be written as ln, it would turn out to be an ln 2CV minus 3Q. Okay, this would be the integration, but there is a coefficient of minus 3 for our q, so we need to divide it by the coefficient of this minus 3, so we just write it as minus 1 divided by 3. Now we can put the limit from 0 to q. Now this is very simple, so integration of dt would be t. If you put the limit, it would again turn out to be t, so t divided by 2 r of rc. Now we can just put the limit, so it would be ln 2cv minus 3q. Okay, if you put the limit as to be 0 to, so it would be 2CV. Then it would be equals to minus 3t divided by 2RC. Okay, Now we can just rewrite this expression in terms of exponential. So it would be 2CV minus 3Q divided by 2CV. It would be e to the power minus 3t divided by 2RC. Okay, this would be the case. Now if we just find out the value of Q, we can just send it to the other side and then we can arrange. Now finally Q value would turn out to be 2CV divided by 3, 1 minus e to the power minus 3t divided by 2RC. Now if we just compare it with the given equation, so it is given as to be, so we can say that it is given as to be this alpha is the coefficient of CV divided by 3. So what would be the value of alpha? So alpha value would be 2. So we can say that alpha would be equals to 2. And what is our beta? Beta is the coefficient of RC. Here we can see that beta is the coefficient of this 3t divided by RC, and this is the coefficient beta. So we can say that beta would be equals to 2. So what would be the ratio alpha divided by beta or beta by alpha? The ratio would be same. It would be 2 by 2. That means 1. So this is the final answer because we need to find the ratio of alpha by beta. So it would be 1. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.